We need to find the limit as x approaches infinity of x to the power of negative 3.5 over x. Now, if you ask what happens as x goes to infinity, you get infinity to the 0 power, which is an indeterminate form, but it's not one that we can directly use L'Hopital's rule on. Now, whenever we have a function of x raised to the power of a function of x, we have some algebra tricks at our disposal involving logarithms. Note that if we just have y, say, we could rewrite that y as e to the natural log of y. That's a legal maneuver, and that is something that we can do to this function right here. If we can rewrite this as e to the natural log of x to the power negative 3.5 over x, you'll notice that that was a legal maneuver because the exponential and the logarithm just cancel each other out, so these two lines are the same. And while this looks worse than the way it looked when we started, we can take advantage of a property of logarithms that says that we can take a power on an argument of a logarithm and move it out in front of the logarithm. That would give us e to the power negative 3.5 over x times the natural log of x. And if I can do a very simple step of algebra, I'm just going to rewrite the power in a fractional form. Now, the limit of just the power here as x goes to infinity is infinity over infinity. That's an indeterminate form. So we can use L'Hopital's rule on just this power here. If we take the derivative of the numerator, we get negative 3.5 divided by x, because the derivative of natural log is 1 over x. The derivative of x in the denominator is just 1. And I'll just rewrite this. Now, what happens to this function as x goes to infinity? Well, the denominator of this power gets really big while the numerator stays at 3.5. So if we take this limit, we get e to the 0 power, and anything to the 0 power is just 1. And that is the answer.